Hello everyone, I'm Rilo, and in this module, we'll be discussing vector operations and space definition. Let's dive in. By the end of this course, students are expected to have these abilities: demonstrate vector operations. Now let's talk about n-space definition, where n-space definition is if n is a positive integer, then an ordered n tuple is a sequence of n real numbers v1, v2, vn. The set of all ordered n tuples is called real n space and is denoted by Rn. And the vector v in Rn is denoted by v, v1, v2, v3, and so on until vn. And the zero vector is denoted by 0 equals to all components are 0. For the vector equivalence, the vector v and w in Rn are said to be equal or v equal to w if all the components in corresponding positions are equal. So v1 equals to w1, v2 equals to w2, and so on until vn equals to wn. For example, if we have vectors v, a, b, c, d, and w 1, -4 to 7 are equal if and only if the a is equal to 1, b equals to -4, c equals to 2, and d equals to 7. And then we have algebraic operations. If vector v and w are vectors in Rn, and if k is any scalar, then for v plus w, we add all the components, v1 plus w1, v2 plus w2, and then vn plus wn. If we multiply v with a scalar k, then we multiply all the components by its scalar. So we have kv1 plus kv2 until kvn. This is also applicable to minus v, where we have minus v1, minus v2 until minus vn. And we have v minus w is equal to v1 minus w1, v2 minus w2, and so on until vn minus wn. For example, if we have v equal to 1 minus 3, 2, and w equals to 4 to 1, then if we want to calculate v plus w, then we add the corresponding components. So 1 plus 4, we have the first component, 5. And then for the second is minus 3 plus 2 is minus 1. And the last is 2 plus 1 is 3. Then if we want to calculate 2 times v, then we multiply all the components of v by 2. So we have 1 times 2 is 2, minus 3 times 2 is minus 6, and 2 times 2 is 4. So we have the 2v is 2 minus 6, 4. Then we have minus w, so the components of w is multiplied by minus 1, so we have minus 4, minus 2, and minus 1. And then we have v minus w. To get that, we subtract the corresponding components. So we have 1 minus 4 is minus 3, minus 3 minus 2 is minus 5, and 2 minus 1 is 1. So the conclusion of the module is, the first one is, if n is a positive integer, then the ordered n tuple is a sequence of n real numbers, v1, v2, and so on until vn. And the set of all ordered n tuples is called real n space and is denoted by Rn. Vectors v and w in Rn are said to be equal if v1 equals to w1, v2 equals to w2, and so on until vn equals to wn. If vector v and w are vectors in Rn, and if k is any scalar, then v plus w equals to v1 plus w1, v2 plus w2, and so on until vn plus wn. kv equals to kv1 plus kv2 until kvn, minus v equals to minus v1 minus v2 until minus vn, and v minus w equals to v1 minus w1, v2 minus w2, and so on until vn minus wn. Alright everyone, that wraps up our discussion on vector operations and space definition. Thank you and see you in the next video.